When you're finding a limit using a graph, it could be a continuous graph like you see here. You still want to look, am I talking about left-handed or right-handed limit? Or if I don't see anything, it's an overall limit. And then you are going to do the method, I would do the method where I say, okay, I'm moving towards -1. So I'm going to go to my x value of -1 here. This is a continuous graph. So if it's continuous, wherever it is at the -1 is your answer. So in this case, 7, right? You could also have situations where it's a piecewise function and it's continuous, like we see on these. Again, you're going to do the same method. Or you could have discontinuous functions, right? So we have discontinuous functions happening. If it is discontinuous, then you could have an infinite limit or a whole. So you could have an infinite limit potentially, however, they have to be going to the same infinity. So you could have a does not exist at all, right? We don't have a real limit here. Or you could have a removable, like we've talked about, like these, where you have a whole. It doesn't matter that at the whole that doesn't exist. It matters, am I approaching a number as I get to that x value? You're still going to do the same thing. You're still going to find that value that you're talking about, in this case, +1. And you're still going to say, well, what is x, what is y moving towards? Even though we know at that number, it doesn't exist. We're moving towards 0.5 or 1/2. So all of those types could happen when you're trying to look at a graph and tell me what the limit is, okay? You could have left and right-handed limits with a graph as well. You're just going to go from the left or from the right, and what is y doing from that side of the graph? So it says, given the function, find delta when epsilon is 0.01. So for this one, remember our definition looks like this. We have your f of x minus your L, and that is less than some epsilon. We're going to try to make then our x minus our c to look like that. And once we do, we will have found delta. Okay? So f of x is given. That is this guy right here. To find our limit, we're going to use one of the methods of finding limit that we would have. In this case, we can just plug it in. So our L is going to be, this is a continuous function. We're just going to plug that guy in. All right, just plug it in. In this case, our limit is 0, right? And so we're going to plug in our f of x minus our L, in this case, not too hard. And then that's less than our epsilon. We're going to simplify this guy. So if we had to subtract something, we would do it. We have it like this. We want it to look like x minus c. So we want it to look like this. That's our goal, is that it looks like that. We do that typically with factoring. So none of these are going to be difficult in the sense of mathematically, just that you need to remember this piece of it. So I'm going to factor that out. And then I am going to divide. And so I get x plus 1 is less than 0.005, which means my delta is 0.005. The first method of evaluating a limit is just see if you can plug it in. Can I plug it in? If I can plug it in and there's no problem, we're good to go. Just because you see a denominator and just because you see a square root does not mean that you cannot plug it in. All right? Always check first. Can I plug it in? If I can plug it in, I'm going to plug it in. And in this case, I can. So to find limit here, I'm literally just going to plug in that -3. And that is my limit. That is my limit. So my first step here is, can I plug it in? Well, I'm going to check and say, well, I have a little bit of a problem here. If I just plug it in, I am dividing by 0. and that's an issue. If I cannot plug it in, the next thing I'm going to do is get rid of my problem. We talked about 2 methods to do this. So we have little caveats under here. You could potentially factor your problem out, right? Or you could rationalize your problem using a conjugate. That's a G. All right. So on this one, I'm going to see if I can factor it. So we're going to say, well, I'm trying to find my limit as x approaches -1. Factors of 4 that add up to 5. Well, that's 4 and 1. All over my x plus 1, right? Yes, I can get rid of my problem here. There we go. So now I'm going to treat this just like the limit as x approaches -1 of x plus 4. I go all the way back to my initial. After I've gotten rid of my problem, I'm going to plug it in. All right, and so now I'm going to just plug that guy in. -1 plus 4, my limit here is 3. Let's look at this next one. This next one, I have a problem. If I just plug in a 3, I have a denominator that says 0. So what I'm going to do here is I am going to get rid of it using rationalizing, okay? Rationalizes, I'm always going to take the guy that has the root and I'm going to multiply by the conjugate. It was -2, I'm going to multiply by plus 2, and I'm going to do that on the top and on the bottom. On the top, I get the a plus b, a minus b special case. So on the top, I get the first one squared. Well, when I square a square root, I just have this, what's in the root. And it's always minus the second one squared. Well, 2 squared is 4. I'm going to leave the bottom alone here, or wherever I didn't initially have that root. We're just going to leave that guy alone. Don't FOIL it. Because on the top, x plus 1 minus 4 is the same thing as x minus 3. Which means I can get rid of my problem. X minus 3 and x minus 3 cancel. Remember, if I cancel everything in the numerator, I need to leave that 1. So now I can do the limit as x approaches 3 of 1 over the square root of x plus 1 plus 2. Now I can plug it in. So I'm going to take this 3 and plug it in. 1 over the square root of 3 plus 1 plus 2. The square root of 3 plus 1 is the same thing as the square root of 4, which is 2. 2 plus 2 is 4. 1/4 is my limit. So this is where you need to remember your 2. There were 2 that I said you want to memorize. All right, so we have the limit as x approaches 0 of sine x over x. That's always going to be a 1 based on the squeeze theorem. And then we have the limit as x approaches 0 of 1 minus cosine x over x, and that's always going to be 0. I'm going to rewrite that tangent. So I'm going to do some manipulation with my rules for trig so you can see why it works, okay? So what is tangent if I rewrite it in terms of sine and cosine? It's sine over cosine. So I have sine of x over cosine x all over 2x, okay? When I divide like this, I end up just multiplying my denominators. The reason that works is because of my keep, change, flip rule. So keep sine x over x, change this to multiplication and multiply by the reciprocal 1 over 2x. So this is all multiplication now. Okay? So far so good? Keep, change, flip. So I'm going to write it like this. I'm going to write it like, I know I want to kind of manipulate the sine x over x, right? So I'm going to say, well, it's the same thing as 1/2 times that sine x over x times the 1 over cosine of x. Does everybody see how it's all multiplication, so it really doesn't matter what order I put it in. Okay? All right, so the limit of any constant is just a constant, right? Do you remember limit theory? So the limit of any constant is just a constant. The limit of this guy is a special case. He's just 1. And for this, I can plug it in. What's the cosine of 0? Cosine, x value of 0 is 1. So 1 over 1 is just 1. What is my limit here?
0.5.
Yep, it's just 1/2. So again, with a graph visually, it doesn't really matter if there's a break, if you're just doing right and left-handed limits. It matters if it is moving towards a number on the side that they've asked about. In this case, they're asking about 0, but specifically they want 0 from the right-hand side. So you're going to take this graph, and from the right-hand side, you're going to move towards the point they're talking about. And that's how you figure out what your limit is. Your limit here is -2. So you don't really even need the function there. The actual graph itself will tell you that limit. So for 34, we have a piecewise function, one-sided limit. So this is 2. You'll notice 2 is where the piecewise function changes, and they want 2 from the right-hand side, which means bigger than 2. So I am going to first say, can I just plug it in to the side that it's talking about? If I can, that's what I'm going to do. So I'm going to take that +2, and even though it doesn't exist over here at +2 because it's not or equal to, I do know it's going to move towards that. So I'm going to take that 2 and plug it in to all of my x's here. Pay attention to order of operations. 2 squared is 4, and then apply your negative. So this is -4 plus 8 minus 5. My overall limit here on the right-hand side is a 1. Now, if I plugged in the 2 at the top, you're going to see the left-handed limit is different. So I have a left-handed limit and I have a right-handed limit, but if they had just asked for limit as it approaches 2, you would have said does not exist. But because they specified right-handed limit, you can give me an answer here. Again, with 36, my first question is, can I just plug it in? Right? And so I'm going to plug in that -1, that's 1, plus a -4, plus 3, I have a problem. Clearly, I can't just plug it in, okay? So then I'm going to go to the same method that I did on the first page. Just because you've started dealing with left and right-handed limits, potentially, this is actually asking for an overall limit. Just because it's asking for an overall or right or left, you're going to still do the same method, okay? They could just have easily have said, oh, from the left-hand side. You can't assume that it's going to be an infinity just because they did a right or left. And this one was just overall, so we're good to go. We're going to do what we did on the first page. We're going to factor. We're going to cancel out our problem. We are going to remember that there was a negative in front already, right? And then we are going to plug in that -1. That's a 3. There we go. We're going to get 1/2 and then apply that -1/2. All right. So just because you get into right-handed limits and left-handed limits, don't forget what you're doing here. Number 38 is different because if you'll notice, I can factor, right? So I have the x minus 3. This is factorable, x minus 1, x minus 1. Don't forget you have the limit as x approaches 1 from the left-hand side. All right. Can I cancel out my problem here? No, that immediately tells me this is going to be an infinite limit. Now I'm just using my logic skills. All right. From the left-hand side, it's something ever so slightly smaller than 1. If I take something smaller than 1 and subtract 3, what am I going to have, positive or negative? So that means the numerator is going to be negative. Something ever so slightly smaller than 1 minus 1. What is that first group going to be?
Negative.
As is the second group. How many negatives do I have?
2. 3.
3. So I have an odd number of negatives, which means my answer is negative infinity. That's how you find those. Number 1 says find the limit as x approaches negative 3 of negative 2x squared plus 1. What do I do with that negative 3? Plug it in. Does it cause a problem?
No.
It does not cause a problem. So plug it in. You should get negative 17, which is your C right there. Plug it in. This is your formal definition of limit. It says given the limit as x approaches 1 of 2x plus 1 equals 3, find delta such that, remember this is f of x, that's not what I want to write with, f of x minus L is less than epsilon whenever x minus 1 is less than delta. So they just want you to simplify this. That's all you're doing. So we are going to do what we've always done here. We're going to take this and simplify it. What does it simplify to? 2x minus 2, right? We're going to factor out that 2 and then divide. This ended up being the 0.005, right? So it won't always be 0.005, but in this case, we've seen that a lot because of the samples that we get. This next one says use the graph of the right at the right, which is over here, to find the limit as x approaches negative 1. So remember, it has to be approaching the same thing. They've given you the little dash line at negative 1. They're approaching 2 different things, negative infinity, positive infinity. That does not exist. That does not exist. Find the limit. What's the first thing I'm going to try here? Plug it in. You can plug it in. It does not cause a problem because when you square a negative 1, you get positive 1 on the bottom. When you simplify this out, what did you get?
1.
Yeah, you should have gotten 1 there. All right. What about this? Can I just plug this in?
Yes.
Yeah, I can just plug it in. It's going to approach the same thing from the left and the right, really. But the problem here is the reason that they said left only is because it ends there, right? If it had been an overall limit, there's nothing on the right to come to it. 3 is as big as you can put in here. If I put something bigger than 3, then I'm going to have a problem. So that's why this is a left-handed limit. If this had been an overall limit, we would have had a problem. There is no graph on the right side of 3. Okay, so the reason that negative is in the top corner is because that's the only side of 3 you can come to. And yes, you can just plug it in and it is a 0. This is just trying to make you remember the rules of limits. If you have 2 functions that are being multiplied, which is what's happening here, you can do the individual limits and multiply them. That's really all they're trying to get you to remember. If this had been addition, you could take the 2 limits and add them, right? So they've given you the limit of f of x, they've given you the limit of g of x, and then they want the limit of the product. We'll just multiply them. Negative 1/2 times positive 2/3. That's going to give you negative 1/3. And so that's just making you think about your rules of limits. You can multiply, you can add, you subtract, you can divide as long as your limit on bottom isn't 0, right? So if you have composite functions or properties like operations of functions, your limits will work similar to the same as just adding and subtracting them, as long as a few caveats like with division. So this does cause a problem. We are going to plug it in, but when we plug it in, we do have an issue. What is my issue when I plug it in?
0.
Yeah, 0 in the denominator. So my easiest thing is to factor, right? I'm going to factor the top factors of -6 that add up to -5. You're not going to use -2 and -3 here. That would be a +6. So just pay attention. People tend to, people tend to factor this wrong for some reason. 6 and 5 are always, they go straight to 2 and 3. But think about your positives and negatives. On the bottom, I have x plus 1. If I can get rid of my problem, which I can, then I can just do the limit now and plug it in. If I cannot get rid of my problem, that's when I'm going to have an infinite limit. But if I can get rid of my problem, get rid of it and then plug it in. -1 minus 6, I am going to get -7 here. This looks like I could just eliminate it. But the problem is that absolute value represents two different things, right? It represents the same number as the numerator when it's positive, right? And it represents the opposite number of the numerator when it's negative. So if I plug in a number bigger than 2, those are going to be the same thing, right? So 3 minus 2, 3 minus absolute value of 3 minus 2. Sweet, right? But if I plug in a number smaller than 2, it's going to be it's going to be -1.
But at 2, it's
So at 2, we have a problem in the denominator, right? Before anything greater than 2 is going to equal a 1 because I'm going to divide the same number by itself, right? Anything less than 2 is going to be -1 because I'm going to divide a number by its positive value, right? Does that make sense? So if they are asking for an overall limit, which is what they are asking for here, there is no left and right, then it does not exist. Because if I were to think about this logically, let's see, 2 is my problem, 2 is my problem. Anything bigger than 2 is going to be a number divided by itself, right? A number divided by itself, which is just 1. Anything smaller than 2 is going to give me a negative number on top and the same exact number on bottom, but just positive. Well, a number divided by itself and one's positive and one's negative is -1. So my graph is going to look like this. I do not have an overall limit. Sorry, it goes all the way to here at 2, right? From the left-hand side, it's approaching one thing. From the right-hand side, it's approaching another. Overall, I don't have one. Had they asked me for a left or right limit, I could have given them that. But overall, I do not have one. This limit does not exist. So if I look at number 9, I have a problem. If I plug it in, I still have a problem. So I'm going to use my rationalizing technique here. I'm going to do the conjugate of the one that has the radical in it. On the top, this is the a plus b, a minus b. So the radical goes away because I square it. Always subtract the square of the next one, which is 3 squared. On the bottom, I have x, and don't distribute him through because we're about to get rid of him. When I simplify this, 9 minus 9 does that, and now I can get rid of my problem. X divided by x. Don't forget you still have a 1 on top when you do that. I got rid of my problem. I can now plug in my 0. So 0 plus 9, square root of that is 3. 3 plus 3 is 6. I get 1/6 here. Now, the fun part about a multiple choice is 1/6 is not one of your answers, right? So none of these is technically the answer on this one. It's why most people don't like multiple choice. So 45-degree angle in what quadrant here? So third quadrant, what is the sine of a 45-degree angle? Sine of a 45-degree angle. Sine and cosine are the same for a 45-degree angle. They are the same. It's the only unit circle one that is the same for x and y. It's square root of 2 over 2. Do you think I'm going to leave him that way? No. So he's going to reciprocate to -2 over the square root of 2. Do you think I'm going to leave him that way? Nope. We're going to rationalize my denominator. Square root of 2 times the square root of 2. I end up with -2 square root of 2 over 2. These cancel, which is why I get C as my answer. So these you should have memorized. These you should have memorized, right? But 1 minus cosine squared is not one that we know. Like, we don't know that one. However, I can factor him. This is a squared minus b squared. So I can factor him to 1 plus the cosine of x times 1 minus the cosine of x. And I'm going to put this one over x. This is why it works. Because of my rules of limits. It doesn't really matter what the limit of this is. I could plug in a 0. Cosine of 0 is 1. 1 plus 1 is 2. So the limit of this is 2. But the limit of this guy is 0. So I end up with 2 times 0. So that is why my overall limit is 0 here. Right? So we don't have a rule for 1 minus cosine squared. We have a rule for 1 minus cosine. The reason this works is because of my rules of multiplying my limits. Multiplying my limits. So this wants us to find the limit as we approach 2 from the left. From the left, all right? So first, I want to figure out if I were to approach it from the right, would it cause a problem? Is it continuous from the right-hand side? Because when they give me a root with from one side or the other, I kind of want to figure out what they're doing here, right? So we are really, really close to 2. So if I did like 2.2, is this going to cause a problem? No, because 2 times 2.2 is going to give me a real number, right? Right? Because it's positive. Now, if I go all the way to 1, right, then I'm going to have a problem. Does that make sense? So I know that somewhere in there, I can no longer do it. Because if my x value was 1, I would have 2 minus 3 inside of the root. This is a problem, right? However, 2 times x can be as small as 3, and I'm still okay, right? So what makes this 0? So the first thing I'm going to do is I'm going to say, so that I can get a picture, what makes this 0? Well, x equals 3 halves makes it 0. Does everybody agree with that? So if I am close to 2, this is going to be 1.5 and 2. If I'm close to 2, I'm some number here, which means it's going to be approaching whatever it is at 2, because 2 does not cause a problem. So if they were asking right at 1.5, I don't have a left-handed limit at 1.5 because there is nothing past 1.5, right? But they're asking about 2. There is something farther left than 2. So I can just plug 2 in here, and it's actually going to be the same from both sides. So left-hand side, right-hand side is going to be the same at 2. So I'm going to plug it in. 2 times 2 is 4. 4 minus 3 is 1. The square root of 1 is 1, right? But had they asked about this number, this graph is going to stop right there at 1.5. So if they had wanted from the left-hand side over here, I couldn't tell them because there is nothing to the left of 1.5. But they asked about 2. And I can give them what it is at 2. There is something farther left than 2 to evaluate to see if it is approaching a number, right? So you have to be careful with square root graphs. If they're asking from a side that, like if you plug it in and get 0, you need to check and make sure that from that side you have more stuff, right? And that it's not nothing on the other side of it, because then it's not approaching anything. You don't have anything to track to see what it's approaching. Can I get rid of my problem? Can I cancel it out? No, I automatically know I'm going to have an infinite limit. Now I just have to figure out which one. Something slightly larger than 0, is that positive or negative? Positive. My 1 is always going to be positive. Something slightly larger than 0 is going to be positive. I am approaching positive infinity. Can I get rid of my problem? I can't get rid of my problem, so I know it's going to be an infinite limit. However, they don't have a plus or minus here, so they better be going the same direction. My 5 is always going to be positive because it's a 5. What do I know about my denominator? Use your logic.
It's 2 of those. 2 of those things. I keep forgetting.
It's squared.
Squared.
Do I have to check left and right to decide if that's going to be positive or negative?
No.
Why not?
It's always positive.
Squared is always positive. So this guy's approaching positive infinity on both sides, which means I can say the overall infinite limit is positive infinity. So it's still an infinite limit, but they're going the same direction. If they had asked me for overall and they were going different directions, I wouldn't have an overall. If they had asked me for right or left and they were going different directions, I could give them right or left. The only way I can give them overall infinite is if it's the same infinity. All right, 15. Can I? All right, so this is kind of a fun one, you know, my definition of fun. They want the limit as x approaches 1. 1 definitely causes a problem that I cannot get rid of, okay? So we'll start here. I have a limit of a constant. What's the limit of any constant? It's just the constant. Now I need to decide what's happening here. My 5 is always going to be positive, and my denominator is squared, so it's always going to be positive. However, I have 2 minus a concept of numbers. It's the same thing as saying negative infinity plus 2. Does the 2 affect it in any way, shape, or form? No, it does not. So this is negative infinity. It's the same thing because the 2 is so minuscule as having this, and you have a negative in front of that. So this is saying at which values is this discontinuous? They didn't say where is this an infinite discontinuity or where is this a whole. That would have been very specific. They want all discontinuities. So I actually don't care about the numerator here at all. I only care about the denominator. I can completely ignore the numerator. I just need to factor the denominator, which is a nice, beautiful factoring. Factors of -2 that add up to -1, +2 and -1, +2 and -1. All right. This is where a standardized test is going to throw you. They're going to try to make you think that 4 makes a difference, right? And it does not. Your answer here is just those 2. Those are the discontinuities. The 4 is just where y equals 0, right? Which is, you know, an intercept, x-intercept. It says let f of x equal 1 over the absolute value of x. G of x is x minus 1. Find all the values for which f of g of x is discontinuous. What does that mean? F of g of x? What does that mean?
Well, f of x into x. So it's like 1.
The other way we would have written this in years past is like this, f of g of x, composite functions. This means take g and put it inside of f, not the other way around. G goes inside f. So when I do that, I'm going to take that f, and where I have the x, I'm going to write my g function. I'm going to write my g function there. All right? This is not asking for limit, so you don't have to worry about, is it approaching the same thing from the right and the left? All this is asking is the value where it's discontinuous. So I just need to know where this is discontinuous. Where is that discontinuous?
X is 1.
Where x equals 1. That's it. They just want to know where it's discontinuous. If they had said limit, then you would have a problem for overall limit because of the absolute value. If they had had a right or left-handed limit, you'd be good to go. They just want, where is it discontinuous? In order for a piecewise function to be continuous, these two need to equal each other when x is -1. So that means x plus 3 must equal 2x minus c when x equals -1. So all you have to do is plug in a -1, right? -1 plus 3 equals 2 times -1 minus c. Right?
That's
So-
not what I did, but just plugged in the top.
So I have a 2 here. I have -2 minus c. Add it over. 4 equals -c. Divide by -1, -4. So vertical asymptote means you have an infinite limit, which means it's non-removable. So it's not asking for all discontinuities for these equations. Both 19 and 20 are asking for vertical asymptotes. So they specifically want non-removable problems. The first one's easy. I have a problem. What's my problem in the first one? I have one problem in number 19. What is it? -3. Can I get rid of it? No, that is my vertical asymptote, C. That is my vertical asymptote. What about 20? I have 2 problems. So in this one, I am going to factor him. How does my denominator factor here?
X plus 2,
X plus 2, x minus 2. I have 2 problems, -2 and +2. Are they both vertical asymptotes? Are they both vertical asymptotes?
No, because you
Why not?
X minus 2.
This, the +2, is removable. He's a whole. The -2 is non-removable. He is an asymptote.